5,
Five.
4, engine ignition, 2, 1, 0. Great. And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed-loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good.
Hey guys, my name is Ismael Trevino and this is the Millennial Way Show. Was there ever life on Mars? It is a question that has intrigued us for centuries. NASA is launching a new rover to the Red Planet to take a step towards answering that question. Scientists believe that ancient Mars was warmer and had rivers and oceans. But did it once harbor life? Today, we have a NASA scientist, Dr. Glaze, Director of the Planetary Science Division at NASA headquarters. And we're going to talk about this exciting mission to the Red Planet and what we hope to do there. Well, actually, the biography and the resume of our guest is very impressive. Dr. Glaze is the director of NASA Science Mission Directorate Planetary Science Division. This planetary science is focused on space flight missions and scientific research that address fundamentally questions of solar system formation and evolution, including understanding planetary environments that can or could have in the past supporting life. Prior to headquarters, Dr. Glaze served as the chief of the Planetary Geology, Geophysics, and Geochemistry Laboratory at Goddard Space Flight Center in Greenbelt in Maryland, and has worked as a deputy director of Goddard Solar System Exploration Division. Also, her research interest includes physical processes in terrestrial and planetary volcanology, atmospheric transport and diffusion processes, and geologic mass movements. Her work focuses on data analysis and theoretical modeling of surface processes on all these terrestrial solar system bodies. That sounds very, very impressive. Dr. Glaze was a member of the Inner Planets panel during the most recent Planetary Science Decadal Survey and has had a role on the executive committee of NASA's Venus Exploration Analysis Group for several years, serving as the group's chair, the president. She received a PhD in environmental science from Lancaster University. Wow, that's quite a resume. Dr. Glaze, thank you very much for being today on the Millennial Way Show. It's such a pleasure and such an honor to have you today with all our audience. Thank you.
My pleasure. Thanks for having me.
Dr. Glaze, it's not every day that you can say that we're getting ready to launch a rover to another planet. Please tell us about this very exciting mission that's launching and what makes it different from previous Mars missions.
As you say, it's not every day we get to do this. So we are very, very excited. Tomorrow morning at 7:50 a.m. on the East Coast of the US, we will be launching our next rover to Mars. The rover is called Perseverance, and it's a very special rover. It's different from some of the other rovers we've sent in the past, although it kind of looks a little bit like Curiosity from the outside, but it carries a very special payload of special instruments that are designed to look for what we call biosignatures. It's an astrobiology mission, which means that we're trying to look at the environment to understand whether or not it could have supported life in the past and whether or not life actually started to take form on Mars about 3.5 billion years ago. So that's a really important part of this mission. In addition to doing the observations we will with the instruments on board, we're also carrying a special drilling system that's going to drill the rocks and soil and take samples and collect them in tubes that are about the size of a test tube. And then we'll leave those on the surface of Mars for our next mission, which is called Mars Sample Return, which will be the first round trip. We'll fly to Mars, pick up those tubes, and fly them back to Earth, where we can then examine those very precious samples in our high-tech laboratories in the US and in Europe and around the world to understand whether or not there is actually evidence of life in those samples.
Tell us about where Perseverance is actually going to land, and why is this crater so special?
Right. So the Perseverance rover is going to land in a crater called Jezero Crater. And this is a very special spot because we can tell by looking at orbital images that there used to be a lake in this crater. We know that several billion years ago, at least 3.5 billion years ago or so, it was much warmer and wetter on Mars. It had a denser atmosphere, a higher density atmosphere, and that there was warm enough and wet enough that there was liquid water standing, a lake in that crater. We also can see evidence that there was a river that flowed into the crater, and when the river flows into that standing body of water, it dropped its sediments and left a delta, just like it does on Earth. When a river flows into the Gulf of Mexico or into a lake, we get a delta. And so all the conditions at that time were right for what we think it takes for life to take hold. It's about the same time that life started to appear on Earth. And so we believe that if life did start to take hold on Mars, the evidence of that would be preserved in that delta. And so that's why we're specifically going to this location. And I'm very excited to look at that delta and see what materials are there and see if we can find any of the biosignatures.
Wow, that sounds amazing. Dr. Glaze, what do you personally think it will be like the coolest part of this Perseverance mission?
Well, I think the coolest part is going to be the science for me because I'm a scientist. So definitely looking at that river delta and looking at the chemistry that's there and trying to decipher whether or not those biomarkers are present. I think that's very cool. Collecting those samples that we know we want to bring back to Earth, to me, that's incredibly cool. It's going to be challenging to decide where we want to take those samples, but very, very exciting.
Dr. Glaze, how does this mission help to set the stage for future human missions to Mars?
That's a great question because that's the other major goal of this mission. In addition to the astrobiology and science goals that we have, we're also doing a lot of things to prepare for future human exploration. We're carrying a special instrument called MOXIE, which is going to convert the carbon dioxide atmosphere of Mars into breathable oxygen. And if we're going to send humans to Mars, we're going to need the ability to make oxygen on the planet so we don't have to bring it with us. So that's very cool. We also are bringing samples of spacesuit fabric and astronaut helmet materials that are part of a calibration target for one of our instruments. And we're going to watch over time how those materials respond and react in that atmosphere, in the radiation environment that's present on Mars. And that will help us learn how to make spacesuits that will keep our astronauts safe when they go to Mars. Two more big things that we're doing, we're testing precision landing capability that we're going to need. We're also testing a technology demonstration of a helicopter, which will be the first powered flight on another planet.
Amazing, amazing. Dr. Glaze, sending a car-sized rover to another planet that is actually more than 65 million miles away, I think is, of course, is not an easy task. Can you talk about the things that make this journey so difficult?
Absolutely. So yes, we'll launch tomorrow morning, and then in about 6.5 to 7 months, we'll get to Mars. So it's a fairly, for planetary standards, that's actually a relatively short cruise time. If you want to go out to Jupiter or Saturn or Pluto, it takes many, many years. So about 6 to 7 months, and that's challenging in itself, just getting to Mars. But the real challenge happens when we arrive at Mars, because when we arrive at Mars, the spacecraft will be traveling more than 12,000 miles per hour. And it has to, in a period of only 7 minutes, it has to decelerate from 12,000 miles per hour to a nice, gentle 0 miles per hour for a soft landing on the surface. And that is incredibly difficult. In 7 minutes, all of that has to be completely automated with thousands of actions that have to happen. It's always a nail biter, but I have confidence that our team is going to be successful again.
Fascinating. Dr. Glaze, this program is watching right now is connected to a lot of countries in Latin America. We're broadcasting in the US coast to coast, also in Europe. We have a lot of audience. What will be your best advice to the new generation of explorers to keep them passionate and motivated to achieve their goals, their dreams?
Oh, my advice is always follow your passion. The things that make you excited, the things that are interesting to you, follow those. And I just want to always point out to people that while NASA and the other space agencies around the world, we think a lot about the science and the engineering, which of course are very important, and we need scientists and engineers, but we need everybody. We have jobs for all different kinds of people. We need money people, financial people. We need arts, people with experience in the arts to help with graphics. We have communications specialists. We have just any kind of job you can think of. Those exist in all of these agencies. So we need all of those skill sets and people who are passionate about space and passionate about exploration. Just keep following those passions.
Dr. Lori Glaze, Director of Planetary Science Division at NASA headquarters, thank you very much for being today on the Millennial Way Show, and Godspeed.
Thank you very much.
Bye-bye. Thank you.
Thank you.